Okay, guys, a very warm welcome to my lesson for today, where we are going to be looking at physical sciences, as you can see there. Paper 1, electric circuits, it's what we are going to be revising in today's lesson. So, guys, it is that time where we need to sign the register. So how you do that, you can just comment in the comment section. The other way in which you can do that, it is to react on the lesson, so that I am aware that there are honorable members who have joined today's lesson. So guys, this lesson is going to be done in this way. I will give you guys an opportunity to participate in the lesson, where all that you need to do, it is to look at that given diagram, quickly analyze it, and then from there we are going to be looking at those questions. So most importantly, just make sure that as soon as you have worked out the first question, you just comment in the comment section with the answer that you are getting. But before we get started, I would like to just check. Can you guys clearly hear me when I speak? And again, are you able to clearly see there on the screen? I just need your confirmation on that one on the comment section. Once you guys confirm for me, then I'll be knowing that we can continue with that confidence that everything is clear on your side. Guys, can someone just confirm and let me know if I'm audible, and again, if you can clearly see over there? Tabby the creator has just confirmed. Okay, then it's fine. So guys, how long am I going to give you to work out the first question? Let's see, you'll need to do that. Okay, so this is how we are going to work it out. I will give you a maximum of 10 minutes to work it out. But as soon as the first 2, 3, or 4 honorable members comment with their answers, then we will continue. So by continuing, it means I will also have to work it out, and then we compare the answers that you guys got versus the answer that I'm going to be getting. So let me see, guys. Did you get my message on that one to say we are starting with the first question, where they say calculate the total resistance, and you will be given a maximum of 10 minutes, but the first few to comment with their answers, we will take it from there. So in response to what I'm saying now, you can just comment in this comment section if you guys did hear the instruction and the comment on that. So that means, let's see, what time? Okay, maximum of 10 minutes. It's what you have to work it out. So let me quickly check something there. It's now 4 minutes. So that means at 19, let's say 15, at 15:15, you should be done with that first question. Guys, did you hear me on that one? I hope so. Remember, to respond to my question, you just comment in the comment section. So this is a live lesson where you guys can respond to all these questions that I'm asking. I'm just not so sure if the message is delivering instantly. Otherwise, if not, I'll just wait in the meantime. Okay, there is Serene, who has just confirmed that all was clear. Okay, then it's fine. I'll give you some time to try and work it out. And then from there, we will compare our answers. So I am also silently going to be working it out. I remember the last time when we tried to do a live lesson, I had some issues with the network. I'm hoping it won't be the same in today's lesson, but for some reason, if it happens, just make sure that you've got a screenshot of this. Then if it happens that it kicks us out, then you know you've got this, and you will have to then work it out and send me via WhatsApp inbox. And then on our live Zoom lessons that we always have during the week, we will revisit the solutions to those questions. So let's see, you will have to say that what's it with okay, okay. On my side, I've got an idea of what you should be expecting as your answer. So let me give you guys a chance to work it out. Once you are done, you comment in the comment section. Then I'll also work it out on my side. Then we compare our answers, because the most important part in this case, it is to make sure that you follow all the necessary steps until you arrive at your final answer. But if for some reason you do work it out and you skip some steps, you therefore won't get maximum marks. So just make sure that as you work it out, you follow all those steps that we have trained you on our previous lessons. So let's see, what time is it now? Okay, it has gone for that. So guys, don't work out from question 1 until question 4. Just do that first question, and then from there, what you need to do, it is to just comment in the comment section with the answer that you got. And remember guys, in a situation where this is difficult, what you need to do, it is to just comment in the comment section and do let me know that it is difficult, just so that we are not all of us waiting for others to comment, because you might find that you're waiting for others to comment, and even them, they are also waiting on their side. So just make sure that you do work it out. Otherwise, if it is difficult, you comment to say, I've given it a try, but it's difficult. Tabi and Serene, are you guys working on it? What's happening on your side? I just want to have a sense of what you guys are busy with there. Are you guys working on it? And everyone else who has just joined, please be aware that we are on the first question. You need to very quickly work it out. As soon as you get your answer, you comment in the comment section. Then from there, I will also work it out and we compare our answers. Almost done. Okay. Okay, then it's fine. At least I've got an idea that you guys are working it out. Okay, there is Tabi. Tabi has got an answer. It's fine, Tabi. Let's just wait for one or two more so that okay, how am I reading it? Yes, okay, the other honorable members are saying almost done. Then it's fine. I will just give you, no, you guys are still within your time. It's fine. There's another one, Shonisani got an answer. Okay. Let's wait for one more to see what answer you guys are getting. So, what you need to calculate there, it is the total resistance. The total resistance of that. Okay, we've got two answers that came through. I'll just be waiting for one more. Then I will also work it out and show you the necessary steps that you need to make sure that you show on your answer sheet. Oh, okay. No, we do have enough answers that came through. Okay, then it's fine, honorable members. It is fine. I will also work it out on my side. I might need to remove this because I assume that you do have that sketch. So it is question number 1 that we are going to be answering. So remember, guys, it is R tot that they want you to calculate, and we only have one formula to calculate R tot, and that formula says R1 that you must plus it with R2 that you must plus it with R3 plus any other resistors which may exist on that electric circuit. So now let us substitute. The first step, it is to write the formula. Next step, it is to substitute. So as we substitute, we can see that we've got our a resistor of 1.5 which is connected in series, 1.5 that we will plus it with. Can you see these two are connected in parallel? So let me just say for R2 we've got resistors connected in parallel. You can't say that you plus it with that and then you continue to plus it with that because this section is in parallel. So that means this formula for R tot, you only plus the resistors which are connected in series. So if you've got a connection which is not in series, you need to convert it from being parallel to being series. That's why I used to say we said it's right. So can you guys see we've got that we need to sort out, and the formula is 1 which says 1 over R parallel is equals to 1 over R1 that you must plus it with 1 over R2. You can plus it with any other resistors which may exist in that type of a connection. So in this case, we only have 2 resistors connected in parallel. So this is how I do it. You still say 1 over R parallel is equals to 1 over, you can start with that 1 of 2 that you must plus it with 1 over that 1 of 3. So you will get a mark for correct formula, for correct substitution, last mark coming from the answer. So remember, when it comes to the answer, you no longer write 1 over R parallel, but you can just say R parallel is equals to, then you rewrite this exactly as it is, but you say to the exponent negative 1. So that as you punch all of this, it helps you to get R parallel, because this alone, it helps you to get 1 over R parallel. But what we are looking for is not 1 over R parallel, but it is R parallel. So you can open your bracket and say 1 over 2, that you must plus it with 1 over 3. And then you close the bracket, you say to the exponent of negative 1. It gives you a 1 comma 2 ohms. Remember to say ohms, so that it indicates that the final answer that we got is R parallel, not necessarily R parallel, but it shows that it is the resistor or the resistors that we were calculating. So now we've got this answer that we can go and substitute it there, meaning finally our R tot, it's equals to that 1,5 that you must plus it with this 1,2 that you just calculated, then you must plus it with 1. Let's see, this plus that, it's already 3, 5 and 2, it makes it 7. Then you can say 0 ohms. The reason you say 0, it's because always when it is not stated in terms of how many decimal places you should round off, always assume 2. But you guys will still get a mark for just saying 3,7, because we know that what comes after nothing, it is just 0. But just be aware that in a situation where you've got that long decimal and they did not specify to say correct to 2 decimal places, just a, or let's say they did not specify to say round it off to whatever decimal places, just always round it to 2, unless if they said round it to 1, 2, or to the nearest, then you will follow that instruction. So let's see, guys, did you see how to work it out? Did you guys see how to work out the first question? You can just let me know in the comment section and give me a feedback regarding what I've just done there. So it's, I think, 3 or 4 of you guys who did get that answer. So I just want to have an understanding of what you guys are going through there. Okay, then it's fine. I am getting some responses that you guys did understand. So I am just going to erase. Do I need to erase? No, before I erase, let me just write the answer for that, which is 3,70 ohms. Or let me just write it as you guys got it and say 3,7 ohms. Okay, there is the next question, honorable members. So on the next question, you guys need to calculate the reading on the ammeter. The reading on the ammeter is what you guys need to calculate. So for this one, I'll give you a maximum of 5 minutes, and I will need at least 5 answers on this question before we can continue with the lesson, meaning proceeding to other questions. So there you go. You're given a maximum of, so that means at 1925, that will be the latest, and by then we should at least have 5 answers. So that means it's either we get 5 answers at least, then we continue, or we will continue after 5 minutes, whichever that comes first. So let's see, guys, did you get the instruction on that one? Okay, 100%. I assume that response of a yes from Tabi the creator, it is I'm responding that yes, we did hear the instruction. I'll just be waiting on my side, and I will also silently work it out. Okay, Serene, okay. Guys, it looks like um the issue that I previously had when we had our lesson seems to be continuing. Not really sure how I'm going to solve this one, but otherwise it's fine. We will continue with those who are still on. Yeah, this issue of this certain brands getting hot needs to be dealt with. Okay, so guys, I won't waste time. I'll also work it out on my side. Remember, we are on number 2, and the only formula is V is equals to IR. So it shouldn't be a complicated one. They usually give you 3 marks for this, where we do know very well that our V is equals to 20. When they say the reading on the ammeter, it means it is the current that they want you to calculate. Already you do have your resistor, the resistance of the external resistor. So that means the I that you're looking for, you will obviously divide on both sides by that, so that that cancels, and then it's like you're having 20 that you need to divide it by 3.7, which is equals to 5. Let's see what you guys got. 5.41. Yes, 5.41. Then you say amperes. If you don't say amperes, it is wrong. You need to state and say 5 amperes. Okay, so now very quickly, let's move on to the next question. Looks like most of you guys did get it correct. So now we move on to the next question. I'll just write the answer that we got there. So guys, just in case if I am disconnected, I will try by all means to come back. Let's see, you guys said we got 5.41 amperes. I will try by all means to come back. Otherwise, if I fail, I'm going to send Moano a WhatsApp inbox to let everyone know. But I'm just curious to know if it is just me or say it's still loading. Let's see. How about now? Am I still disconnected, honorable members? Or can you guys see? Can you guys hear me now? So the problem was this phone. I don't know why these iPhones keep on getting hot. I really don't know why. I like this brand, but it looks like I will need to change it. It okay now. Okay, then it's fine. Anno's world. Then let's move on to that next question, which says the reading on V1, V2, and V3. So this is your V1. There it is your V2, and then there it is your V3. I think those V's are clear. So let's see if you guys can in on this one. I'll give you some time, a maximum of 5 minutes. Once we are done with this one, we'll do that last one, and then we should be done for today. So, okay, looks like I'm also running low on battery, but it's fine. We are almost there. A maximum of 5 minutes to work out that one. If the first two comment, then we continue. I'm glad you guys did confirm that everything is okay now, but it looks like the temperature wants to rise again. But before it does that, let's see how far we can go on that question. Guys, are you still working on it? Are you guys working on it? Question number 3, the reading on V1, V2, and V3. Remember, once you get your answer, you just say V1 equals this, V2 equals this, V3 equals this. In one comment, you need to answer all those 3 questions, or give answers to those 3 questions in one response or in one comment. Still no comments on the answer. Okay, let me see how far my battery is. 8%. Okay, still fine. Guys, are you still working on it? Maybe let me not rush you guys. You might find that to me they seem to be easily doable, but I might be rushing you guys, so just wait in the meantime until you work it out. Okay, there we've got a Tabi the creator. Remember to uh, answer all those three V's, and then in one comment you'll say V1 equals to this, V2 equals to this, and then that. Just so that we avoid a situation where we've got too many comments by same person but on different V's. Guys, what's happening? Are you still working on it? Serene, Anna's World, what's happening? Are you guys still working on it? I hope so. Hope so. Let me chill. Give you guys some time and some space to work it out. Mhm. Let me see. Let's see. Let's see. We still have only one was coming. Okay, then it's fine. We will then work it out. I'm just not so sure if I'm still audible and if you guys can still see. But it's fine. I'll just make an assumption that I'm struggling. But wait, the creator, what are you struggling with? Okay, I'll just make an assumption that it is difficult and I will work it out. Let me do this just so that you guys can see that and that. One is answer. Okay, so let's see. It's question 3. It's question 3 that we are dealing with. So let's see. Obviously, the formula is this one, which says V it's equals to IR. So now, when we get to V1, we need to substitute the current that is passing through V1. Even the R, it has to be the one on a V1. So now, what is the current passing through the resistor where V1 is connected? It is that same one that we got initially, being 5.41. That is 5.41 volts. So now we are done with that first one. But remember, guys, how did I get that? Let me show you. I think I've actually skipped a mark there. So your current, it is 5.4. Is it 5.41 or 40? No, it's 5.41. And then what is the resistor where V1 is connected? It's 1. So that's why we say this times 1, it is just 5.41, then you say volts. So now we get to V2. Still the same formula. V is equals to I times R, where V2 is connected. The current, it doesn't change. It is 5.1 because even this one of 1.5 ohms, it is connected in series. So that is why we say the current that is passing through there is the same as the current that is passing through there, because that section up until there, and also on that other side up until there, it is connected in series. So now you have your 5.4 that you must multiply by 1.5, which is equals to 8.1 volts. And then when it comes to V3, you need to say the current that is passing through that V3, and again the resistance that you substitute there must be where that V3 is connected, and the V3 is connected on the parallel connection. So now that means the current that must split within that parallel connection, it is still that 5.41. But you need to be careful with R. The R is for the combined and not for 2 or 4, 3. So the question now is, as you were calculating your R parallel, what did you get? You might find that you guys are not seeing what I'm writing. So I was saying when it comes to V3, the formula remains I times R. So the current that is passing through that parallel connection, it is still that same. You just need to be careful on the R to substitute the R parallel and not R for one of the resistors. So what is it that you got as your R when you calculate in parallel? So let's see, you had to say 1/2, that you had to plus it by 1/3, close, and then you had to say to the exponent of -1, and then you get your 1,2. Yes. When you were calculating your R parallel, it gave you 1,2 that you had to now multiply by 5.41. Then you get 6.50 volts for that one. That's what it's rounded off to 2 decimal places. Okay, so now let's see what you guys got. Did I make a mistake somewhere, honorable members? Why is it like we are getting different answers? Let's see. But wait, guys. Maybe I'm the one who made a mistake somewhere. That. No, I did not make a mistake. Yes, because say I rounded off to that. Yes, but you see where I'm getting confused is where you guys are getting. I think I made a mistake on V3. Yes, because you guys are getting 16.2 volts on V3. So I'm also wondering, how are you getting that? Because remember, when you take V1, you plus it with V2, you plus it with V3, it must take you back to 20 volts. So that's how it works, honorable members. So your V1, we got 5.41 volts. V2, we got 8.10 volts. Then V3, we got 6.50 volts. Even there, if you say 0, it's still fine. But just be careful, honorable members. Someone could also say that after calculating V1 and V2, then you can say the total V minus those two V's, it will give you the remaining V. That's another way of doing it, if you want to do the shortcut way. So what I'm saying is, instead of you working it out that way, so that means you could say V total must be equals to V1 that you plus it with V2 that you plus it with V3, which is what? V1 you got 5.41 that you must plus it with V2, which is 8.1. But remember, our V total is 20. So we are looking for V3. So what I'm saying is you're going to say your V3 is equals to 20 minus that, and that's when it was going to give you that 6.5. Is it 6.5? What did we get? Yes, it should therefore give you 6.50 volts, not 16. I'm not sure how you guys got the 16, but otherwise this is how you work it out, honorable members. So on the last question, let's see. Now they're saying the current passing through the 2 ohm resistor and 3 ohm resistor. This is going to be our last question. Can someone just let me know if you guys hear me on that last one when I'm saying let's now calculate number 4. As you answer this, please do let me know if you understood how we work out question number 3, where we do the reading on V1, V2, and V3. So guys, for term 1, we will just need to make sure that we do as many questions as possible on electric circuits, and then the other topics we will do those on Zoom. At least if we can master this topic, then we know that we've reduced a lot of work. Oh, okay, I wasn't on the latest charts. Them one is saying, yeah, V3 we used the single resistance instead of the parallel. Okay, then it makes sense. That's where you guys got that. But the thing is, you see now, if you use this one of 3, let's say you say 3 times that, it's not fair because you're discriminating. What about the 2 ohms? So in this situation where you have those two, you can't just